We're going to look at exponential growth. Oh, it's terrible. I'm not. Growth and decay here. So first thing we're going to talk about is what is an exponential function. You're used to like a linear function, y equals mx plus b, right? So you have an x in there. A quadratic, we have like x squared plus b at x plus c. Those are quadratic functions. There's a lot of different versions of that. In an exponential function, the power is to our variable. Okay, so our power is actually the x.
Okay.
Yeah. And then you have your a and your b, and we'll talk about what they stand for. A is usually called the starting point. T, right? It's technically also like your Y-intercept. Okay, so I'm gonna say or Y-intercept. Okay, and then b is the ratio that is growing or decaying by, is I guess a good way to say it. Ratio of growth or decay. I'll try to define that a little better. Growth or decay. So, if you notice, I've kind of given you almost two separate formulas for growth and decay. And for growth, what's happening? Well, imagine you're putting money in a bank, right? You're increasing. That's why you have a plus. And for decay, you're decreasing. So subtraction. So they kind of make sense, the addition and subtraction. But instead of writing just b, we would write 1 plus whatever our growth rate is. And the reason being is because 1 represents 100%. So if you're growing, you always have whatever you start with plus, oops, I didn't mean to do that. Whatever you start with plus a little more. Okay, so whatever the percentage or whatever the rate is, you have what you start with, that's your 1, and then whatever your growth rate is. Decaying is whatever you start with, and then you subtract by a little. So you're actually decreasing in size, amount, more and more and more, and that's what this R stands for. And sometimes they'll break questions into that, so they'll have to actually break up your B and calculate what it's going to be. Okay, so let's look at this concept like on a graphing calculator here. I'm actually going to use the letters A, B. Okay, so let's use sliders. Okay, I got 1 and 1. I don't want 1. I want a growth rate of at least 2. Okay, so this is what an exponential function looks like. It's very, very close, and although it says 0, if we were to actually zoom in, if we were to zoom in immensely here, that's the wrong way. It's hard to see. They call this something called an asymptote. So if you actually look, it's
vertical asymptote.
Yeah. And this one's a horizontal asymptote. It's never actually touching 0. Okay, it's just really, 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 really close to 0. And then, and this is for growth. Okay, because right now I have b being a positive number. It's greater than 1. Okay, it's growing. Now, if you notice, the a value is 1. That's the Y-intercept. And the reason that happens is because if you put any power to 0. Okay, so that's what the x value is 0. Any exponent to the power of 0 is just 1. So 1 times a. So if I change the a, the y-intercept moves up and down. Okay. So our growth rate here is 1 plus 1, which is 2. So this is like growing by like 100%, you could say here. And the larger this gets, so the faster this growth rate becomes. Right. And you'll see how it becomes steeper and steeper, that line. Okay. So as our b value or our growth rate increases. Okay, and then what happens, as we decrease it, it gets smaller and smaller. And then we get to a point, okay, so, I wanted to catch it in between. Just at 1, it becomes flat. And then once we're in the decimal values, okay.
It goes the opposite way.
Yeah, it goes the opposite way. And that's only the decimal value. So I'm going to go from 0 to 10. And I think my steps are going to be 0.5. Let's see if it'll do it. Yeah. Okay, and it jumps across. So you'll see it jumping up every single time. In fact, I actually want to go to 1 now. And I want it to go up by 0.1 every time. So I just changed my slider here. So you can see that these are all decimal values, and they get steeper the other way. So the closer they get to 0, the faster the decay is happening. It gets very, very low. And then as it gets closer to 1, the decay is a little more gradual. 1 gives us that flat, and then once we're over 1, we would actually jump back up. It would become a growth rate. So with that being said, what that means is we can put some like parameters, I guess you'd call it, around b. If b is greater than 1, okay, we have a growth rate. If b is between 1 but greater than 0, so it's usually like decimal values, we have what's called a decay rate. Okay, and the negative completely flips things. It changes all of it, what we're doing. Okay, so you guys learned a bit about radicals, and a radical is, if you remember exponent laws, it's written something like this. You have like an A and a B, right?
Mm-hmm.
Well, you can write that as an exponent. It could be x of b over a. So you just have a fractional exponent. So whatever those numbers are, they actually exist. Maybe it's like a seventh, right? You can have the seventh root of something. Or normally, let's use a more common one. Let's do second. This is the square root. So that would be x to the power of a half. So if we go look over here, let's put some values in. Let's say y is equal to 3 times bracket. Let's say the growth rate is 400%. It's huge. To the power of x. Okay, so there's our orange one here. If we wanted to know what the square root value of that 5 would be, you could say something like x equals a half. And where they intersect, okay, that would kind of give you, actually let's do it to 1 here. Okay, this would give you the square root of 5. When the x power is 0.5, that means like square root. So all those little decimal x values, and they don't talk about them too much, those are the ideas of roots, whether it's square root, third root. These things will tell you, because they all actually exist along here. So if I made a slider, we'll call this x1, and I want x1 to equal, I want a slider. I want my values to be from 0 to 1, is that what I want here? Yes, I want them to be halves. So let's jump across. Oh, it's not showing us the best example here. Oh, I need the original. That's why. Let's put that in. Y equals 5 to the power of x. You can kind of see how it moves along our value in there. Maybe that part's confusing, but radicals are exponents, just written in different ways. So that's how you kind of relate a radical to exponent. It's just like a small group of exponents, of exponential values.